Hello, welcome to the Colorize 2D Texture Processing Guide. Texture processing is an essential step before you can color your sprite textures. In this guide, we'll explore this process using 4 different texture examples, highlighting how varied textures necessitate unique processing settings to create an ideal painting environment. Firstly, let's delve into solid pattern textures. These are what we consider clean textures. A clean texture means it has a number of unique colors that are precisely discernible by the human eye, ensuring the texture's accuracy and clarity for further coloring. Next, we will examine AI-generated pattern textures, typically labeled as dirty due to their complexity. Despite the apparent simplicity, where you might see only 3 unique colors, these textures harbor thousands of subtle color variations, most of which are slight deviations indiscernible to the naked eye. Through Colorize 2D's advanced cleaning settings, we tackle these nuances to simplify the texture without losing its essence. For our third example, we focus on stylized textures, often manually created by artists using third-party software. At first glance, these might look clean, but a deeper inspection reveals thousands of unique noise colors, invisible to our eyes. These colors are typically the result of anti-aliasing, smoothing, and compression algorithms. Colorize 2D is designed to process these nuances effectively, ensuring the texture's original quality is maintained while making it ready for coloring. For our last example, we will focus on pixel art style textures. In each of these examples, we'll demonstrate how Colorize 2D's innovative features, such as auto-clean strength, maximum search depth, and auto-merge colors, empower you to adjust and refine textures. These tools, designed for both efficiency and control, enable artists to prepare their textures with confidence, whether dealing with the cleanliness of solid patterns or the complexity of AI-generated designs. We start with a solid pattern texture, one we're familiar with because it's our own creation. The first step is selecting Sprite texture mode. This takes us to the processing settings, equipped with 5 key variables to customize our texture processing. Help boxes under each variable provide guidance. These can be disabled in the Settings tab if you prefer a simpler view. Diving into the variables. First on our list is the alpha cutout. This setting filters out pixels with alpha values below our chosen threshold. The default is set at 0.9, ideal for textures with full opacity. Since our texture meets this criteria, we will leave this at the default. Next are auto clean strength and maximum search depth. These settings are crucial for reducing noise from anti-aliasing, smoothing, and compression. However, since our texture is clean and hasn't been subjected to these effects, we'll keep these at their minimum settings. Finally, we look at merging strength and number of steps. These are essential for textures with a wide color range, as they help group similar colors to simplify the texture. But our texture, being simple and having just 3 distinct colors, doesn't need such adjustments. Therefore, we set these to the minimum as well, reflecting the straightforward nature of our texture and bypassing the need for advanced merging. Once we've set our variables, the next step is to click the Get Colors button and allow the texture to process. It's important to remember that because you have full control over these settings, the processing time can vary greatly. Factors like the values you've chosen, along with the texture's complexity and size, might extend processing time significantly. In some cases, particularly complex tasks could even lead to running out of memory. Gaining experience with Colorize 2D will help you strike a balance between processing quality and time. Until you're comfortable navigating these settings, we recommend using this tool in a separate project. This way, if processing takes longer than expected, you won't risk losing any crucial unsaved work should you decide to force close the application. In contrast, for simpler textures like the one in our example, the processing time is considerably shorter, taking only a few seconds. This quick turnaround is due to the texture's simplicity, highlighting how straightforward textures benefit from faster processing times with Colorize 2D. With the processing complete, we can now observe that all three color groups within our texture have been accurately processed and are ready for editing. Our next example takes us into the realm of AI-generated patterns. At first glance, you might mistake this for a solid, clean pattern similar to our previous example. However, appearances can be deceiving. While you may only discern 3 colors, this texture is composed of thousands of colors, each with minor variations that might seem solid but are actually complex. AI-generated textures, as of now, can't produce clean, solid patterns. The slight variations in color that look solid are the result of thousands of colors blending together. Manually editing each of these unique color regions isn't feasible since they number in the thousands. But with the right processing settings, we can simplify this task by automatically merging these myriad colors into the 3 primary groups you perceive. It's crucial to understand that the algorithms process the texture in 2 main phases: cleaning followed by merging. The cleaning phase, managed by auto-clean strength and maximum search depth, typically reduces noise from anti-aliasing, smoothing, and compression. Although not all AI-generated textures exhibit this noise, many do, due to the AI's training on textures processed with these algorithms. For our current example, we'll presume the texture is free of such noise, setting both auto-clean strength and maximum search depth to their minimum values. If we encounter noise, however, we can always return to adjust these settings. Given this is a dirty texture with thousands of colors, we initially set the merging strength to its maximum. Our objective is to condense these colors into just the 3 groups we perceive. As you can see, our initial attempt merged the colors into a single group, which wasn't what we aimed for. This showed us the setting was too high. So we adjust it downwards, seeking the sweet spot where the thousands of colors are grouped into the 3 distinct color groups we originally perceived. Notice some seams between the color groups. This is what we consider to be noise. This kind of noise, often embedded in AI-generated textures, can create unwanted boundaries. To smooth these out, we increase the auto-clean strength. This step is all about finding the right balance, ensuring we remove the seams effectively while keeping the texture's integrity intact. Typically, we maintain maximum search depth between 3 to 9, but starting at the default value of 3 is advisable. This setting determines how far the algorithm searches from noise pixels to find a suitable color group for relocation. Moving to our stylized texture example, we anticipate encountering noise colors, but we'll start by setting both auto-clean strength and maximum search depth to their minimum values. Given the expected complexity of this texture, including potentially thousands of colors due to noise, our initial goal is to merge color groups closer to what we perceive visually. This time, we're adjusting the number of steps to 6 to enhance the quality of our grouping. Remember though, while increasing the number of steps can improve grouping quality, it also raises processing time significantly. Proceed with caution. After attempting to group the colors, we'll address the noise. It's important to note that completely eliminating noise colors isn't necessary. Our advanced diffusion painting algorithms are designed to handle textures rich in detail or noise, which we'll explore in a separate guide. And, if needed, manual grouping is always an option. The aim here is to automate as much of the process as possible without obsessing over perfection, as absolute precision isn't always required. A word of caution regarding the auto-clean strength and merging strength. Setting these too high could lead to a loss of texture detail. Mastering these settings will take practice and a thorough understanding of their effects. For deeper insights into how these functions work, we recommend consulting the documentation. Now we'll explore our pixel art style example. It's important to note that all models in this scene are part of a single sprite sheet texture. This is advantageous because it allows us to paint the entire scene in one go. Pixel art typically doesn't have noise pixels, which streamlines our texture processing. Therefore, we can minimize auto-clean strength and maximum search depth without compromising on quality. As we adjust our grouping settings, remember, pixel art's simplicity lets us increase the number of steps to 8 without significantly impacting processing time. We'll also keep the merging strength on the lower side. While such settings might usually raise concerns due to the potential for increased processing time, the smaller size of pixelated textures like this one allows us to prioritize quality. For larger textures, such as those in 4K, caution is recommended. Beginners should opt for less intensive settings initially, adjusting based on experience and the texture's response.